With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So in this question it is given that we have to consider the following points in which 4 points are given. We have to select the correct one. So the first point which is given to us is that cesium is the strongest reducing agent as 1A group element. Well, if you see this is not the case. Why? Because it's not cesium, it is lithium who is the strongest reducing agent. In 1A group. This is because the reduction potential of lithium is minus 3.04 volt and cesium is minus 2.927 volt. So the reduction potential gives the value for is inversely proportional to the reducing power. So smaller the value for reduction potential, greater the reducing power. Therefore, you can say that lithium has the smallest value of negative 3.04 volt, so it will have the strongest reducing power. And hence, the option number A is incorrect. Now we have the second option, that is BOH twice is amphoteric. If you see BOH twice, what happens in BOH twice? That is amphoteric. It reacts both with acids and alkalis. So the reaction involving the reaction with acid will be, it will form a complex of this type. So if I take an acid of H2SO4 plus BOH twice, so I'm going to get BeSO4 plus 2H2O. So this is the formation of salt barium sulfate. Now, if I am reacting this with an alkali like NaOH, what happens is NaOH plus BOH twice, I am going to get a complex of Na twice BeOH4. So this is the product which I am going to get. So basically it dissolves both in acid and alkali. So therefore we can say that BOH2 is amphoteric and option number C will be correct. And now we have the third statement, that is the density of potassium is less than sodium. So the density of potassium is less than sodium. That is not the case. It is density of potassium is less than sodium. What happens over here? That is in the option. Density of potassium is actually less than sodium. It is because, as we know, for density formula is density, that is denoted by rho, is equal to mass upon volume, and here volume is equal to 4 by 3 pi r cube. So the radius, as we go down the group, if you see the placement is, so sodium is first and then potassium. So down the group the atomic size is increasing. Atomic size increase. So you can say that atomic radius increases down the group. Okay. So what happens over here, when atomic radius is increasing and volume is directly proportional to radius, cube of the radius, and you can see in the density part it is inversely proportional to volume. So we can write this as it is inversely proportional to the cubic root of radius. So density, if radius is increasing, definitely the density is decreasing. So if you see the case of sodium, the radius is less compared to potassium, and potassium has higher radius. Therefore, since radius of potassium is more, and if you put this in this formula, that is density is inversely proportional to the radius, cubic root of radius, so you will get that potassium has low density compared to sodium. So option number C is going to be your incorrect option. Now you have your fourth option, that is in alkali metals, lithium, sodium, potassium and rubidium, lithium has the minimum value of melting point. So if this is the case, what happens over here is ions get larger down the group, which will imply that distance between the bonding electrons, that is your valential electrons, and the nucleus goes on increasing as we move down the group. So what will happen is it reduces the overall attraction between the two. So reduction of attraction between the nucleus and electron, that is said to be effective nuclear charge, is decreasing, or you can say your attraction forces is decreasing. Therefore, it is easier to break the bonds when we go down the group. And hence we can conclude that cesium will have lower melting point than others. Therefore, if we see the given set of statements, in this we concluded that the potassium has less density than sodium, and also that beryllium hydroxide is amphoteric. Therefore, option number B and C will be a correct answer. So the statement is B and C are correct. This will be the option correct. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.